Good morning. Today we are going to learn regarding system and clock memory. So we need to understand what is system and clock memory and its usage. So in this session, I will explain the usage of system and clock memory in PLC. So coming back to our conveyor system example. So this is our conveyor belt example, conveyor system. Here we added one light that will blink in 3 modes. So here we have added one light that will blink in 3 modes. The light will blink with 1 Hz frequency if the conveyor system detects the object. So if this object is detected at this point, if V1 detects this object, the light will blink at 1 Hz frequency. 1 Hz means 1 time per second. Frequency 1 Hz means 1 cycle per second, so 1 blink per second. Okay, if the conveyor is under running condition, the light will blink with 2 Hz frequency. Means if the object is detected, I have clicked the start option, means the conveyor is under running condition. The light will blink at 2 Hz frequency, 2 cycles per second, means it is blinking 2 times faster. If the object reaches the end of the conveyor belt, the light will blink continuously in on mode. Means the object is reached at the point B3, the light will blink continuously. So in the beginning with 1 Hz frequency, so we will start the conveyor system. During running conditions, it will blink with 2 Hz frequency. And when the object reaches the end, it will blink continuously. Means it is in on position. It will not blink, it will just turn on. So as you are acquainted with our conveyor system example, so you know what is our conveyor system example. So the object, when the object reaches at the B1, B1 is one sensor, it will detect the object. When it detects the object, it will blink with 1 Hz frequency. And when it reaches the point B2, our stopper will move backside and object will cross the B2 and our stopper will come to normal position. When object at B3, our light will turn on continuously, means our conveyor will stop and object will go away. Again, second object will come into the position. Already regarding conveyor system, I have explained. So for the light is an output module because it is blinking. It's an output module. For light, I have taken an address of 6.2. Okay, so let's go into the PLC and start working with this light as one more output device we are going to add into this PLC. So we will follow a procedure. First, to go to the PLC tags, input and output. Here I have added the light as output 6.2, output as 6.2 as light. Okay, now I need to use system and clock bits in this PLC. So go for devices and networks, device configuration. Just click on this PLC. When you click on this PLC, bottom it will be shown in this manner. General, Profinet, everything will be there. Select the pulse generator. You just open this pulse generator. You will open system and clock memory. Just click on this one. Here you can say system and clock memory. Okay, just click down. So you have to enable this use of the clock memory bits. Enable this use of the clock memory bits. Once you enable, if you give 0 means it is selecting 0 byte. 1 byte is equal to 8 bits. So 0 byte means 0.0 to 0.7. So the clocks are assigned in this manner. Then 0.0 is assigned with 10 Hz clock. 0.1 memory bit is assigned with 5 Hz clock. So all these clocks you can use in the PLC. Okay, now go for the PLC tags. Create a new tag table. We are going to name as a system clocks. This one as system clock, and I'm going to add all the clock bits. So my address is MB0. So MB0 is my clock bit address. So I have added here. Otherwise, I can add with M0.0. This is a boolean, this is a byte. M0.1. M0.2. M0.3. M0.4. M0.5. M0.6. M0.7. Okay, these are my clock bits. Okay, show all tags. So sorry to say, I have intentionally made small mistake. So I have used the same bits 2 times here. So already for the clocks, these bits are assigned because we have created in the system. We have enabled the system clock bits. Again, I'm using the same bits once again for this purpose. Means I have created once again MB0 means 8 bits. Again, I have used it for with another name tags. With the name of tags, I have using the same clock bits. So when you use these tag bits and as well as clock bits with the same memory address, just like an overlapping. When you overlap the bits, your function will not work properly. So when you want to blink the light with 2 Hz frequency, it will not blink. It will show some error, but that error will not be detected in the PLC because this is not a means here the error is means even system can't detect these kinds of errors. So in order to overcome these things, you are not supposed to create these kinds of tags. So delete this one. Delete these tags. So you can use the same clock bits. Okay, I'm going to copy this one. Copy and new tag table. In this tag table, I'm going to copy this one. So I have copied all the clock bits here. Okay, so I have got all the clock bits. Now what I will do is I will simulate this clock bits and check its performance. So you know how to simulate this one. So first you need to compile this one and use simulator. Start simulation. Load your program into the simulator. Load. Finish. Now run the simulator. Now open this simulator. create a new project. Open this one. Okay, now I'll open this one completely. I'm going to open the system sim tables here. So I'm going to enter that addresses here. So I'm going to enter address of MB0. This is my memory bit has 8-bit address. So next one is I'm going to enter M0.0, M0.1, 0.2, M0.3, M0.4, M0.5, M0.6, M0.7. There won't be M0.8, it will be 8-bit address. So now you can see in this 8 bits you can see how it is toggling. So with each bit will be toggling with some frequency. So M0.0 is toggling with 10 Hz frequency, means 10 cycles per second frequency. M0.0 is the last one. Okay. And M0.1 is toggling with 5 Hz frequency. M0.2 is toggling with 2.5 Hz frequency, 2.5 cycles per second. Okay. And M0.3 is toggling with 2 Hz frequency. M0.4 is toggling with 1.25 Hz frequency. So similar manner, all bits are assigned with some sort of frequency. These frequency values are also listed here. You can see it. And now we are going to use these frequencies in our conveyor belt system. So when the object is at the position 1, it has to blink very slowly. Our light has to blink with very slowly, one cycle per second. Means 1, 0, 1, 0. Like that it has to blink. When it is in the conveyor system, 1, 1, 0, 1, 1, 0, 1, 1, 0. Like that it has to blink. When it reaches it at B3 position, it has to be like 1, like that, means continuously in on position. Okay, so now we are going to make this circuit in our PLC. Okay, now what we are going to do is we'll turn off this CPU and we will close this one. We don't save this one. Okay, now our part is we'll go into the main program. So we are going to work with the network 3. Here we are going to add a lightning system here. So I'll write light, my network name as a light. So first we will come from the beginning. So first I will take this one. This one will be my B1 sensor. And my B1 sensor sees the object. Light has to blink with 1 Hz frequency. But conveyor is in the off position. When I click the start button, then only my conveyor will start. Okay. So I'm going to click here my conveyor position. So conveyor is in the normally closed. Okay. And it has to blink with one frequency. So that frequency is 1 Hz frequency. So click the clock. You're going to open with this one. Select 1 Hz frequency. And in the output, I'm going to place a light. Okay. Next, I'm going to open one more branch. Now, my conveyor is in the on position. Means this is our conveyor in second case. And it has to blink with a 2 Hz frequency. So this one I again select the clock, and it has to run with 2 Hz frequency. And it has to connect it to my lightning system. In the third case, when object reaches to the end, means B3 sensor has to glow. When B3 sensor is in on position, light has to be in continuous on position. So this is our ladder diagram. So I think you can understand easily this one. Now I'm going to simulate this one. Compile. Load. Run the CPU. This is a simulator CPU. And this one. Create a new project. Okay, open, expand this one, and go for the sim tables. Load all tables. Okay. Now you can see here clock bits are there, as well as our bits are also there, light bits are also there. So once my object is detected and B1 is there, means the first lightning has to blink with 1 Hz frequency. So it is blinking with 1 Hz frequency. The light system is blinking with 1 Hz frequency. So I'm going to monitor this one. So you can see with 1 Hz frequency, the light is blinking. Okay, means the first ring is blinking with 1 Hz frequency. Now in the second case, I'm going to start this one. Once the conveyor is start, means what is happening? Once conveyor is in the start position and B1 is in the off position. Now we're going to see. So the light will blink with the 2 Hz frequency. It is much faster than the previous rate. Previously it was blinking with 1 Hz. Now it is blinking with the 2 Hz frequency. Now see the case. Now B3 is enabled. When B3 is enabled, so our conveyor is in the stop position. Now it is blinking continuously. There is no blinking at all. It is in the continuous run mode. So in this way, we can use the system and clock bits for our analysis purpose. Thank you.